Alright, welcome to 9-2's lesson, which is on also transformations, and we're going to be talking about translations in this particular unit on and off of the coordinate plane. Okay, so translations from middle school was when we just moved things. Alright, so we're talking about Jennifer is in the band, and she is, at the start of the halftime show, her position is 2, 4 on the coordinate plane. So Jennifer is our X on the coordinate plane. So Mr. King is going to tell everyone in the band to move 2 yards to the right on the field and then 4 yards up on the field. The band's transformation is shown as the diagram, and Jennifer's new position is marked with an X. So here was the band. These arrow notations tell us where they end up to get this new graph over here. This type of transformation is called a translation. On the coordinate plane, a translation is described by a function of the form x, y arrow, x plus some a value and y plus some b value, where a and b are positive or negative constants, aka numbers. So in the above example, our a is a 2 value and my b is a 4 value. They got that 2 because she went 2 to the right units, and then they got the 4 from going 4 up. Okay, so the x-axis is dealing with left or right, and so if you go left or right, that is going to affect your a value, and if you go up or down, that is going to be attached to the y value. So a way to remember it is the x-axis goes left to right, so if you're moving left to right, it's with the x value. The y-axis goes up and down, so if you're moving with the y value, or up or down, that'd go with the y value. Okay, you can think of a translation as a figure sliding up or down, left or right, or diagonally. During the translation, every point in the figure moves the same distance in the same direction. The distance in the direction is called the directed line segment. In the diagram, the directed line segment of the translation is shown by the arrows. So here is my directed line segment. It said I went over 2 and then up 4, which is kind of like the hypotenuse connecting it in the direction. Okay? So again, it kind of gave you some math terminology over here. Translation is rigid motion where every point is moved in the same distance in the same direction. Directed line segment is a distance and direction of the transformation. Okay? So again, translation, move it. That's what it is. All right. Moving on. I want you to complete the table to show how the translation affects the 4 marching band members. So we have Blake, PJ, and Josiah, who were all in the marching band last year. Their pre-image is their starting image is over here, and you're going to figure out where they ended up. Fabian, you're going to work a little bit backwards. It gives you his image, so it gives you where he ended up, and you're going to figure out where he started. Okay? So use the diagram above to complete the table for Blake, PJ, Josiah, and Fabian. So press pause and try those. All right, so Blake was at a 2, 4, and then Mr. King told everyone to go to the right 2 and then up 4. So if I add 2 to my x values and add 4 to my y values, he is going to end up at a 4, 8. So he went right 2 and then up 4. Same thing for PJ. PJ is going to the right 2, which will give you a 5, and then up 4. 7 plus 4 is 11. Josiah started on a 1, 8. Going to the right 2 would give you a 3. Up 4 would give you a 12. Now Fabian is going backwards. All right, so instead of adding 2 and adding 4, I'm going to subtract 2 and subtract 4. So Fabian's going to be at a 5, 7. So 7 take away 2 is 5, 11 take away 4 is 7. So let me know if you have any questions on how I found the image. I just went in the forward direction, so plus 2 and plus 4. Again, if you're going from the image to the pre-image, you're going to do the reverse or the opposite. All right, so take a look at number 2. Mr. King is arranging the band in a rectangle. He then directs the band member at 6:10 to move to 4:13. The numbers on the coordinate plane show the yards of the football field. So for the band member to move in a translation, how should each band member move? So if he tells one person to go from 6:10 to 4:13, what should everyone else do? And then try number 3. Bianca was positioned at a 2, 4, which is the X on the graph. her friend tells her that her new position is described by the function x plus 3y minus 2, and her new position is at 7, 0. Is her friend correct or is her friend incorrect? Tell me why or why not. Okay, so work on 2 and 3 based off this information, and then we'll go over our answers. Right, so for number 2, every band member needs to go to the left 2 and then up 3. So based on this move up here, going from a 6 to a 4, that's subtracting 2, or moving to the left 2. And again, from a 10 to a 13, that is moving up on the y-axis, so up 3, because it's positive. Okay, Bianca's friend was incorrect, so she actually switched up your x and your y values. So if you go subtract 2 with the x values, and then you add 3 to the y values. So it should actually be x minus 2, because you went left, and then y plus 3. So for example, if she moved to the right, this would be a plus 2. If she went down, it would be subtract 3. So it very much follows along with the x and the y axis. Okay? Let me know if you have any questions. So we're going to overview kind of the multiple ways to write a translation. So again, a translation is a rigid motion on the coordinate plane that moves every point of one pre-image to another image constantly, a constant distance. So in the same direction, the same location. So there are several ways to write this. So we just learned the mapping method, which is x comma y arrow, x plus 8 comma y minus 3. So this would be read, it's going 8 on the x-axis, so it's going to the right 8. So I'm going to go ahead and write that. Cool. So that means you go to the right 8. This is in the positive direction. This minus 6 would mean down 6 because it is negative. Okay? So the positive and negative tell you which direction, left, right, up, or down. The number tells you how far. You can also write it in words. So let's take a look at this one over here. You can say 8 to the right as well as 6 down, kind of just like the information I pulled from this. Or there is a new way of writing it, the middle one, called the notation. So big T stands for translation over here. And you've got 2 numbers with a comma in between. So the first number is your x coordinate. The second number is your y coordinate, how far it moves. So for example, T with an 8 and a negative 6 means positive 8, hence plus 8, and negative 6 minus 6. Okay? So those are the 3 ways that you can write a translation, etc. So let's look at one more example. So I have a point A. It is located at negative 6, 4. What are the coordinates of A prime? So A prime is going to be the image, what happened afterwards. So A is your pre-image, the original one. A prime, this little tick mark up here, is the new image. After a translation, negative 2, 3. So that means take away 2 from your x values, add 3 to your y values. So I'm going to do it below it. Take away 2, and then add 3. And then you just figure out what that would be. So negative 6 take away 2 is going to be a negative 8. And then 4 plus a 3 is going to be a 7. So my A prime is now located at the point 8, 7. Okay? So this is just the number that we would put underneath it and add or subtract it. Okay? So that is the translations. So you are again moving it on the coordinate plane, meaning adding or subtracting. And it is a rigid motion because it's not changing size or shape. Okay? All right. Thank you for watching 9-1 and 9-2. So now you can get started on your practice. Let me know if you have any questions about translations and rigid motion.